In this section, we're going to talk about another type of function called a rational function. Rational functions are the quotients of polynomial functions. The domain of a rational function is the set of all numbers except the values that make the denominator 0. In previous sections, we found the domain of rational functions without using that specific name, rational function. So example 1, find the domain of each function. A, we have f of x equals x over x squared minus 9. So same thing that we did before. We want to find all of the x values that make the denominator 0 and exclude those from all real numbers. You can either factor this or solve by adding 9 to both sides, and then the square root property would say x equals plus and minus the square root of 9, which is plus and minus 3. So x can be anything except 3 and negative 3. So in set builder notation, we write that like this. Okay, set builder notation on the homework, you'd be filling in this part right here. And as an interval, this would be negative infinity to negative 3, and then negative 3 to 3, and 3 to infinity. B, f of x equals x plus 3 over x squared plus 9. Okay, so if we find the x values that make this denominator 0, we have x squared plus 9 equals 0. If we try to solve this the same way, x squared equals negative 9, x equals plus and minus the square root of negative 9. And the square root of negative 9 is 3i. Okay, so 3i is not on a graph, and so we do not exclude that from the domain. So we would say that the domain is all real numbers. Okay, also remember, another way to express all real numbers is the bold-faced R symbol. And example 1c, f of x equals x plus 5 over x squared plus 3x minus 4. So again, we're taking the denominator, finding which x values make it equal 0. Okay, and often these will factor, or you can use the quadratic formula. This one, factors of negative 4 that will add to 3, 4 and minus 1. Okay, so negative 4 and positive 1. So my domain, x cannot equal negative 4 and 1, or as an interval, negative infinity to negative 4, negative 4 to 1, 1 to infinity.